Hello students, welcome back. In this video we will see about de-arrangements and also we will talk about some important results on points. So let's have a look. Till now we were talking about the arrangements of items. Now we will talk about de-arrangements. So if there are n things which are arranged in a row, then the number of ways in which they can be de-arranged so that r things occupy the wrong places, while n minus r things occupy their original places. So there are r things which occupy wrong places. This will be given by nc n minus r into dr. So de-arrangement of r items and n minus r items occupy their original places, where dr is equal to r factorial. There is a simple formula for the de-arrangement, that is r factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, and the last term will be minus 1 power r. So if r is even, I will get plus 1, and if r is odd, I will get minus 1 by r factorial. Now if there are n things that are arranged in a row, if the number of ways in which they can be de-arranged so that none of them occupies its original places. If none of them occupies their original places, that means nc 0, no object occupies original places, and all the objects should be de-arranged, so dn. So dn will be, we will replace this r by n, so we will get dn as r factorial into, and here also we will get n factorial. Now let us talk about some important results about points. So suppose if I have n points in a plane, out of which m are collinear. So the total number of different straight lines that can be obtained by joining these points is nc2. So there are n points, total there are n points, so let me draw like this. So m points are collinear, so there are m points which are collinear, p1, p2, p3 up to pm, and the rest are non-collinear. So the points which are non-collinear we will represent on this arc. So the total number of different straight lines that are possible is, first of all we will write nc2. Whenever we will join any 2 points out of this, we will get one straight line. But when I join any 2 points out of this m points, I will get the same line. So I will subtract them. So minus mc2 plus 1. Why plus 1? Because there will be one line that I will get. If this is AB, then this one line, that is AB. Now if I want to find out the total number of different triangles that can be formed, then that will be given by, first of all, if I connect any 3 points out of this n points, so total there are n points, and out of this n points, if I connect any 3 points, I will get a triangle. But when I connect any 3 points out of this m points, I will get a straight line. Suppose if I take p2, p3, p4, I will get a straight line because these 3 points are collinear. So I will have to remove all these cases. So mc3 I will remove from nc3. So mc3 will be total number of ways of selecting any 3 points out of this m collinear points. Now what are the total number of diagonals in a polygon of n sides? So the total number of diagonals will be given by, if I choose any 2 points out of this, I will get one diagonal. But if I choose 2 adjacent points, if I choose p1, p2, then I will not get a diagonal, but I will get a side. So I will remove, so there will be such n sides. So I will subtract n from nc2. So total number of diagonals in a polygon will be given by nc2 minus n. If m parallel lines in a plane are intersected by the family of other n parallel lines, then the total number of parallelograms so formed will be given by mc2 into nc2. So total, if there are m lines, parallel lines like this, and n parallel lines like this, so if I select any 2 parallel lines from this set and any 2 parallel lines from this set, I will get one parallelogram. If I select any 2 lines from this set and any 2 lines from this set, I will get one parallelogram. So mc2 into nc2. The total number of triangles formed by joining the vertices of the convex polygon of side n is nc3. So the total number of triangles that will be formed is nc3, of which the number of triangles having exactly 2 sides common. So if there are exactly 2 sides common, then the number of triangles will be n. If there are exactly 1 side common, then the total number of triangles will be n into n minus 4. And if no side is common, then the total number of triangles will be n into n minus 4 into n minus 5 divided by 6. So these are some important results about points that you should remember. If you have any doubts, then you can log into www.askIITians.com and then you can click on the discussion board, which will redirect you to this page where you can see Ask Expert on the right hand side. From here you can select the category of the question and you can post your question here for free, and the experts at Ask IITians will answer your question within 24 to 48 hours. So students, this was all about permutations and combinations. We have seen this through various subtopics like fundamental principle of counting, then we saw NCR and NPR, then we saw distribution of like objects. We have also seen summation of numbers, and we have also covered our last topic, that is some important results on points. So I hope you liked this video. Thank you for watching my lecture on this topic, that is permutation and combination. Stay tuned on askIITian.com for more videos on other subjects also. Thank you. Have a great day.